All right, our last video on this section of blood will be very short. As far as blood groups, of course, they are part of when you study hematology. A little bit of information about those. Like it was saying here in 1910, identification of the ABO blood antigens gene. Today, there are 31 different genes known to contribute to the surface features of red blood cells. You get that from your parents. In the genetic lottery, whatever your blood types of your parents were, of course, they're going to contribute that to you. One quick thing about the whole ABO part, and very simply, A and B genes are always dominant over O. For you to be type O blood, you have to get two recessive genes. And oddly enough, it's the most common blood type. But if your mom is one gene, you get both of them from your parents, one from your mom, one from your dad. If your genotype, your genetic code, if you got an A from your mom and an O from your dad, you're going to be type A blood. Or if you're type A blood, you can get an A from your mom and an A from your dad. If you get a B from your mom and an O from your dad, you're going to be type B blood. Or you have two Bs. To be type O, you have to get two O's. And the type AB, which is the rarest, you get an A from your mom and a B from your dad. They are codominant. One of the things, agglutination means clumping. That's when red blood cells will stick together and they won't flow through organs correctly, especially kidney, lung, brain. So basically would cause somebody to die if it's a bad reaction. So you're trying to avoid that when you're trying to give blood transfusion, that kind of thing. There are four main groups, AB, and O. We kind of did that. They all have surface markings, surface features, little proteins called antigens. And then antibodies are like the globulins we were talking about. Those form in plasma and they're floating along in plasma. All right. I'm going to bounce over to here. Now, I did this diagram in your lab, but here is type A blood. There's an A antigen. Here are the anti-B antibodies. Here's the B. This is type A blood. This is type B. See the B antigen. And all of these are the anti-A antibodies. And you can see right there, a little point would fit perfectly in that A antigen. So the goal of anything is you cannot get the same antibodies and the same antigen in the same area. The antibodies will bind to this. That's their natural tendency. And then you'll have clumping and then blood flow and then you'll have issues. Type AB, you have both an A and a B antigen. After you're born, your immune system develops these antibodies, and they develop the opposite antibody type. If you're type A blood, you end up with what are called anti-B antibodies. Love computers. If you're type B, you end up with these anti-A antibodies. And in the case of AB, because there's both antigens, they don't develop any antibodies. So they have no antibodies. If you're type O, see there's no antigens on the surface, then you end up with both antibody types. That's the way that it works. This is clumping. This is normal blood slide, but that's what clumping looks like. And see here's the red cell being mixed with the same antibody type, and you see the antibodies are then sticking and clinging to the antigens, and then you have trouble. This is a great diagram. So here, antibodies actually do look like this. They're Y-shaped. You can see the ends are different. These are called the antigen receptors. See the A antigens. See how the A antibodies are shaped perfectly to fit there. The B antigen. Here's the B antibodies to fit perfectly. So that's a great couple of diagrams. So, yeah, you do have to know. So here is blood type A. They have an A antigen. They have anti-B antibodies. Who can they donate to? A and AB. Because remember, AB, they're called the universal recipients. They have no antibodies. So they can receive blood technically from anyone. Who can they receive blood from? A and O. O is called the universal donor because they have no antigens, so there's nothing to cause trouble. B has a B antigen, the anti-antibodies. Who can they donate to? B and AB. Who can they receive from? B and O. You always can receive from the same blood type. And AB, like I said, they're called universal recipients. As far as B, this means who can they receive from? This is donate to, receive from. Yeah, B and O. AB, they have both antigens, neither, none antibodies. Who can they donate to? Their own blood type. And I'd mentioned this in the lab. It does matter with the pluses and the minuses. Who can they receive from? All. O have no or neither antigens, both antibodies, called universal donors, can only receive from O. And we did this in lab. Now the Rh factor has to do with the antigen D. That's what makes you plus or minus. If you do not have the antigen D, you are negative. And the terms are you are Rh negative, Rh positive. And like it says here, 87% of the population is Rh positive. So you have to remember when you're doing blood transfusion, positive can give to positive only. Negative can give to both groups. The reason you can't donate to negative if you're Rh positive, because this antigen will be seen as a foreign invader, just like they got vaccinated. There would be no trouble the first blood transfusion, but the second one, they will have developed what are called these down here, these anti-Rh antibodies. And so then you would have a problem. Then you'd have the clumping, and then you'd have a blood, what's called a transfusion reaction. And you don't want that. Okay, that's the thing. And RhoGAM comes in here, and we don't really cover this. You're not going to be tested, but that's showing if a mom has a positive fetus and she's Rh negative, you try to shield the fetal blood from the mom so she doesn't develop these antibodies. And then the next pregnancy, if the fetus was positive again, the body would attack it like it's a foreign invader. That's where the RhoGAM shot comes in. All right, guys, that is it. I hope these help, and I will be in contact with you throughout this, in the future. Thank you.